All right, off we go into a new unit and a new chapter. This one is going to be involving random variables. And a lot of what we learned in chapter 4 will be applicable to this because this involves a lot of probability. Now, before you drop over unconscious in your chair, this is not going to be as heavy duty a probability as what we dealt with. There will be a little bit of combinations, but it's not going to be tree diagrams or anything too complicated. So having said that, let's just roll forward and we'll see how it goes. So we did an activity where we counted the number of siblings in the family, including yourself, and we were sure to include all the stepbrothers, stepsisters, half-brothers, half-sisters, any kid that's part of the family counted. And this is the distribution that we had. We had one out of, the values for the random variable are going to be x. X is the number of siblings. And this is the way we typically denote a random variable. We use a capital letter that's more or less towards the end of the alphabet, like random variable W or X or Y or something like that. That is not necessarily a hard and fast rule. You can have a random variable D, for example, if you want that to apply to the number of dogs in a household or whatever. But in general, we usually use that sort of notation. We choose somebody at random from the class. Is X a categorical or a quantitative variable? Well, the values for X are 1, 2, 3, 4. Those are numerical. So we're going to call this quantitative. That would be as opposed to eye color, like brown-eyed, blue-eyed, silver-eyed, green-eyed, that sort of thing. Those are just categories of eyes. But here, the number matters. Here, there are more siblings for this group than there are for this group. So this is quantitative. Are all the probabilities between 0 and 1, and we should really include the word inclusive. In other words, that means that 0 could be an okay value and 1, just not the ones in between. And we do actually have a probability of 0 for one of them. So yes, all of them are between 0 and 1. That is one thing that we have to make sure of in order for it to be a legitimate random variable distribution. And what do you get when you add up all the probabilities? All right, well, okay, we can add them. So we had 6 over 14, or means plus, 4 over 14, plus 2 over 14, plus 0 over 14, and then we have two instances of 1 over 14. Remember, these are all ors, so we're adding them. And we're going to get something out of 14 since we have a common denominator. So the sum of the numerators is 6, plus 4 is 10, plus 2 is 12. 13 and 14. So it's 14 out of 14, which is 1. And that's the other thing that we have to verify, that all of the probabilities add up to 1. So we have a legit random variable probability distribution. For number 4, interesting question, is 5.7167 a possible value for X? Remember, X is the number of siblings. And actually the 5 part of it would be okay, but the 0.7167 means that we have a partial person running around, and that's not possible. So no, you cannot have a fraction of a sibling. So if I were to ask what is the probability that X, let me get rid of that 5 real quick, that X equals 5.7167, that would equal 0, because there's no such thing. So describe in words what the probability that X is greater than or equal to 3 is, and then find that probability. Just as an aside, that would be the same as the probability that X is greater than 2, right? Because that would include 3 or 4 or 5 or 6 plus. And this would also include 3 or 4 or 5 or 6 plus. There's actually 2 different ways to write this. But either way, in this case, X greater than or equal to 3 is the probability of greater than or equal to 3 siblings. And that would be the probability of x equals 3 plus the probability that x equals 4 plus the probability that x equals 5 plus the probability that x equals 6 or more. So we can find that starting with x equals 3, that'll be 2 out of 14 plus 0 out of 14 plus 1 out of 14 plus another 1 out of 14, and that'll be 2, 3, 4, 4 out of 14, which we could reduce, but let's just leave it. Or we can do like a complement rule, 1 minus the probability that x is not greater than or equal to 3, which would be the probability 1 minus the probability that x equals 1 plus the probability that x equals 2. So that would be 1 minus, let's see, 6 over 14 added to 4 over 14, which is 1 minus 10 over, whoops, left my 0 off, 10 over 14. That's 14 out of 14 minus 10 out of 14, which gives you exactly the same thing. So there's two ways to go about it. So then for number 6, it says, describe in words what the probability that x is greater than 3 means. That's the probability of greater than 3 siblings. And again, as an aside, that's going to be equal to the probability that x is greater than or equal to 4, because you don't include the 3. It's just the 4 or the 5 or the 6 plus. So this would be, let's see, 4 or more, that's 0 over 14 for the 4. Let's see here, 0 out of 14 plus 1 out of 14 for the 5 plus 1 over 14 for the 6 or more, and that would just be 2 over 14, which again reduces. Let y equal the time in minutes it takes a randomly selected student to run a mile. Okay, this is different. All right, it's not something that you can count. Don't you need something like a timer or a stopwatch or something in order to get this answer? All right, so would 5.7167 be an okay value for y? And that would be certainly. Because with a stopwatch, you're not limited to, okay, it's got to be either 5 minutes or 6 minutes or 7 minutes. It can be any of those, plus all the values in between. It just depends where the stopwatch stops. So this would be 5 minutes and 43 seconds. Now the 5 minutes come from that number there. The 43 seconds comes from the decimal part. So if you multiply 0.7167 times 60, which is seconds, you'll get about 43 seconds. All right, so this would be considered continuous. And we're going to go over why. The original that we had up here is going to be discrete. So let's move on to the learning targets and figure out why that is. Well, here's our learning targets. Learning target number 1 is to verify that the probability distribution of a discrete random variable is valid. And these are the two things that we checked on the first page. A valid distribution has all probabilities are between 0 and 1 inclusive, and we did have a value that was equal to 0 for, what is it, 4 siblings? And the other thing that we have to make sure is happening is that the sum of the probabilities equals 1. Once you have met both this one and this one, then you have a valid discrete random variable distribution. For learning target 2, calculate probabilities involving a discrete random variable. All right, just like chapter 4, all the rules for probability from there apply to this particular chapter. Just keep in mind that the probability that x equals or greater than or equal to 3 and the probability that x is just greater than 3 are different values. We saw that on the front. Greater than or equal to 3 includes the value of 3. But for the greater than 3, it doesn't. So those will give you two different answers in a discrete setting. And then classify a random variable as discrete or continuous. Discrete have a fixed set of value gaps. So look down here. Do you see how 0 and 1 and 2 and 3 don't include anything in between. Like there is no number like 2.43, like we're going to get to that. So the example with this would be number of siblings. Anytime you see the phrase number of, that will be discrete. And just an easy way to know if you're in a discrete setting, the values are countable. Like number of siblings, you either have 1 or 2 or 3 or 4 or none. Those are all countable. Continuous, on the other hand, all possible values with no gaps. So if we were to be able to show a continuous random variable, we would have to find a way to show all possible values. Right? There wouldn't be gaps like we have down here. So example would be height. Well, isn't height something you need to have measured, like with a tape measure, or I don't know, one of those scales in the doctor's office where they lower the height thing onto your head? Weight would be a scale. Time would be sort of like a stopwatch. So when something is continuous, an easy way to remember it is that these random variables will be measurable. Okay, if it's something that's a measurement, then it will be continuous. If it's something you can count, then it will be discrete. So on to the application. And we've seen this application scenario before. This is the university that posts their grade distributions for its courses online. And then we had the Business Statistics College in a recent semester had 45.7% A's. So here are your A's. And 36.2% B's. All right, so here are your B's, C, D, and E. And what we're seeing for the values of the random variables are grade points. So you get A equals 4 grade points, B equals 3 grade points, C equals 2, and so on. So if you look at these, it kind of looks like we're a little bit more weighted toward the better grades, which I guess is a good thing. But we'll get to that. So is x a discrete or continuous random variable? It's discrete because x can be countable numbers, 0, 1, 2, 3, 4, but not a value like 2.43. In fact, if I were to ask what is the probability of getting a grade point of 2.43, that's not possible. So that would be 0. For number 2, show that the probability distribution of x is valid. All right, all the probabilities are between 0 and 1 inclusive. So check that one. And then added up all the probabilities and we got 1. So check off that one. The answer is that the probability of distribution of x is valid. Then explain in words what the probability that x is greater than or equal to 3 is. That's the probability that the grade is greater than or equal to 3. Which would be a B or an A. So the probability that x is greater than or equal to 3 is 0.362 for the B and 0.547 for the A, because you can get either an A or a B, and that adds up to like almost 82%, which is why these grades are so good. And don't forget too, that this is also equal to the probability that x is greater than 2. It's the same thing. So write the event that the student got a grade worse than a C using probability notation. What is the probability of this event? All right, you can do either the probability that x is less than 2, which would be a D or an E. I guess it's not really an E, that would be an F, right? Or you could say it's the probability that x is less than or equal to 1. Okay, either way, they're equivalent. So that would be the probability that x equals 0, which is this, or the probability that x equals 1, which is this, and or means plus. So there you have it. So only about 4% of the people score that low. There you have it. Hopefully that's a good start into random variables. We will pick this up with 5.2.